Okay, so thank you very much for the introduction, and of course thanks to Vera for the invitation. It's a great pleasure to be a returning guest and to also witness for the second time in a row this incredible level that is established across disciplines for 2.5 days. It's, I say this with a certain degree of envy, of course. So thank you very much for the invitation. Today let's start from the title. Yeah? The title, Spaces of Machine Learning, and the work wants to be, the discussion today wants to be about how to think about the role of machine learning algorithms. From now on, I will just say machine learning, but by that I want to include somehow a mixed bag of things that fall under the broad category of artificial intelligence and the role on design, and how to think about basically large quantities, the larger scale in architecture. The presentation will also unfold in the reverse order in which it has been constructed. It is actually work that is generated through applications of these algorithms to design, but today I will end with those and somehow give a lot more weight to a number of figures that I think are relevant to mobilize knowledge about machine learning and design. I will call them prosthesis, and hopefully in the course of the presentation it will become clear what I mean by that. So spaces, at least two, the space of computation and architecture being intertwined and not somehow separated anymore. And in a way, I think it's of course, is a new condition of architecture, but at the same time, it's not, because if you think of Christopher Alexander and the city is not a tree, you always have this kind of duality between the architecture as a form of organization and architecture as a physical space. Somehow, of course, Christopher Alexander took a certain position on how these two things needed to be perhaps not linked, so the city is not a tree. So the general idea is somehow to expand these two domains by merging them. So this is the problem, in a way, not a problem in a sense of something that needs to be resolved, but something that needs to be discussed and addressed, and that is the emergence of pieces of architecture that really have no real place in the history of the discipline in itself. This building is perhaps best explained by images like this. It's basically a computer made into a large building. Of course, it's not computing in silico, but it's still a computer. And in many ways, I think that I want to try to discuss this in a slightly different way. You know, some of my colleagues have tried to redesign objects like this to make them better. I don't think this is the issue at stake. Like I said, the issue is try to mobilize what is going on and try to understand it in a, if you like, larger framework. And this is what I would say a prosthetic approach to this issue could give us. Yeah? If this works, what we get is somehow the ability to animate the knowledge, the techniques, the history, somehow trapped in images like this one, and to make them amenable for further discussion. And this formula, amenable to further discussion, I think is quite interesting, and maybe it will come back in the presentation. So there are also a certain number of, let's call them dissatisfactions with how things are described that have been helpful in propelling the work. I think there are 3, or let's say 2.5. The first one is that most of the creative work, which of course, design belongs to, still focuses on the glitch, the error, if you like, the reassuring feeling that the machine fails, and therefore, as an exotic fascination, that failure can be celebrated. I think that perhaps this is unavoidable when it comes to technological innovations. It's a sort of phase we need to go through. But the fact that these buildings do exist, and they don't really fail that much, seems to suggest that this way of discussing the role of automation and computation in architecture is not particularly fruitful. So I think that if it's irony that is driving this kind of work, I don't find it particularly ironic. It's not ironic enough, and it actually needs to be taken, I think, more seriously. The second one is an old habit, if you like, of architects, which is first, I think, established by Stephen Kuhn's 1966 at MIT, which labels CAD, as in the broad ecology of software that help design, as perfect slaves. Yeah? So I think this is no longer the case. The computer is not obviously a perfect slave anymore, and that needs to be treated differently. The half point is not a critique, but I think is actually work that I hope I can help in discussing, and that is the work of Dan McQuillan, who suggested that perhaps one of the dangers of big data and automation in design is a return of Neoplatonism, no? The idea that somehow behind this veil of data there are some truths that can be delivered. And hopefully this presentation helps to further remove us from these images. So architecture has always been computing. Yeah? The architecture is a form of computation itself, and has always been a form of also of a repository for information and data. This is true even when architecture is only drawn or even talked about. So this is true from the classical tradition of Cicero and Quintilian. It's true for memory palaces. And I think that the relationship between spaces, traces, sign, and signals is very much part of the conversation that I would like to unroll today, and sketching out some lines which may be useful when it comes to machine learning and design. So somehow this is something that has popped up several times over the last 2 days, and that is somehow a topographical crisis. No? The topographical crisis, in a way, for us that work perhaps more closely to architecture, means an impossibility to be cartographers, as a real difficulty in drawing up maps, basically, of a certain space. So I think there are 3 kind of areas of crisis in this sense. One is that the 2 basic elements of spatial mnemonics, which are hierarchy and retrieval, have been steadily losing their centrality in the history of information. Mnemonics still plays a part in our everyday experience of city and buildings. The legibility of a city through streets, patterns, and landmarks relies on its persistence in time. If, on the contrary, objects are constantly moving and finding their position according to no consistent logic, this very quality of space is lost. With that, of course, comes the fact that the ability to draw a map is also producing the other ability, which is to forget. And this also has lost its relevance because, of course, anything can be remembered. And finally, we can still draw maps, and in a way, Ludger in the first evening spoke very eloquently of how easy it is to see, for instance, a map on your mobile phone, but that's not really the point. Maps as conventional drawings, of course, don't make much sense in this environment, and they are replaced by algorithms. Yeah? Algorithms become really a way of, if you like, sectioning some sort of mass and returning an image which is obviously an image which is bound by the rule of the algorithm, so it's not some sort of absolutely objective true images, but nevertheless is one. So I think there is also something that has come into crisis. A little note, because this has always been an interesting thing that I always think about, and this is Goldstein writing about the history of computation before the birth of the digital modern computer, and trying to summarize what he thought the contribution of Leibniz to computation was. And these 4 points I still think remain an interesting kind of chart to think about what computation can be. Of course, the 4th one being particularly interesting, I think. So, first prosthetic figure is cryptography. Of course, let's first of all address the fact that this is Alberti. Alberti, of course, is not mostly known to be a cryptographer, but was a cryptographer. And this is the cipher is the device that he invented. But beyond the anecdotal, I think that cryptography is a very interesting domain, because it somehow is the art of having a dialogue, if you like, having a conversation with a domain that is completely not comprehensible. In fact, in cryptography is exactly the ability to make something incomprehensible the reward. And that is, I think, quite a useful thing to think about. So somehow working with machine learning algorithms has also meant to confront some sort of impenetrable, inhuman computational processes. Cryptography, of course, has a long history of dealing with these inhuman domains, characterized by a complex relation between pattern and randomness, and of course their alien dimension, which somehow we have to wrestle with. This long-standing issue in the space of computation, this is a long-standing issue in the space of computation, and cryptography, in fact, plays with transparency and opacity, with obscurity and intelligibility. Its role in history has not only been connected with diplomacy and secrecy, but also with the playfulness arising from the creation of a system of sign with a special, highly unstable relationship to meaning. Of course, this echoes quite closely with a discipline such as architecture, which constantly wrestle with the inability to fix these relationships with one another. The key element is the cipher, of course, as an element that tunes these two domains. Sorry. No. So the cipher is the element that tunes these two domains. The cipher is not something that is given, it's something that needs to be created, needs to be designed. It requires a great deal of artistry, whilst being solidly resting on strict rules. It captures somehow elements of randomness and pattern, and therefore I think becomes a very interesting key. Of course, to think about this work, of course, cipher also means number. And here I would like to add perhaps a third way to think about this, which is by using an expression that I know exists in Italian, but maybe exists in other languages too, which is cifra stilistica. No? Cifra stilistica means literally stylistic cipher. And it's an expression we use to describe work of arts, basically. Now, when we speak of the cifra stilistica of a certain piece of work, we are trying to capture its mood, its kind of general image, its salient qualities. And without ever thinking that the cifra stilistica can be a total substitution for the original, that is able to understand the whole of the originality, but somehow has an ability to make the original intelligible to us. So I think, that is an interesting, I think, useful way to think about the relationship with these sort of alien dimensions. The second prosthetic figure is the labyrinth. Now, the history of knowledge, we know, and I'm quoting Eco here, has been, if you like, an evolution, a progression from the tree to the labyrinth, right? And the labyrinth, of course, marks, at least in Eco's narration, the end point of this evolution. Of course, the labyrinth, again, has a kind of close relationship to cryptography with its method, its histories. And the labyrinth here is not used so much as a historical metaphor, but rather as a way to reverse back known models, or say as a method, but rather as a way, a prosthesis, to set idea about machine learning into motion, into some kind of echoing chamber with other ideas, and perhaps help to discuss them. So labyrinths are interesting because, once again, the mathematical resolution of labyrinths pertains to the domain of topology, not to that of geometry. And therefore, there are mostly relational models, which hopefully we will see comes back also in the later application of these ideas that I will show. So the labyrinths are such for everybody but the person that designed them. So in a way, the architect, technically speaking, should be the only person that knows the key to the labyrinth, but not anymore. In a way, when we operate with this alien world of artificial intelligence, the architect is in the labyrinth, is not the person that can any longer claim some kind of overview or controlling gaze. Pierre Rosenthal has extensively written about labyrinths. And Rosenthal is an interesting figure, of course, French mathematician, but also member of Oulipo, so connected to the literary group. And he has classified labyrinths according to two main types. The unidirectional one, the one that is basically made up by a single path with no bifurcations, the one in which Ariadne's string, if pulled, would return without making any knot, basically. And then the second one, the one in the center of this image, which is the Irrweg, in which bifurcations do exist. First of all, I apologize if my pronunciation of a German word was terrible, but it's the one with bifurcations, and in which all corridors lead to a dead end except for one. Of course, this has a topological nature, which is one in which if you were to pull the string, you would get knots. But Rosenthal discusses the notion of the myopic algorithm as an interesting idea on how to compute these objects. So I think that in the three characteristics of, in the computation of this object, the notion of the myopic algorithm is quite interesting because, of course, has to do with some sort of localized knowledge which can be tested out and tentatively scaled up, generalized, without ever knowing whether this generalization is totally correct or in need to be edited, to be changed. So I think that is also an interesting way to think about how to relate with this alien domain. So the notion of exploration, of gradual learning, of the intelligence of the traveler, the ability of the traveler through the labyrinth to turn signals into traces, traces into signs, are interesting steps, I think, on how this concept could work. Okay. Of course, there's a third figure, which is the, not technically speaking, not really a labyrinth, but let's call it a lattice for now, but one that gets closer perhaps to the kind of architecture of machine learning, and in which This lattice has no clear spatial hierarchy, no up, no down, no directionality, no interior, no exterior, no center. Somewhere else, I discussed a figure like this, comparing it to the Mnemosyne project by Aby Warburg. But here, I think that I want to stress perhaps slightly different ideas, which have to do with the fact that every node in this lattice is connected, actually, not technically, is connected to all the others. The lattice cannot be unraveled, as it is infinite, and different from the other two types, has no interior or exterior. As any node can lead to any other node, to connect two nodes is an open process that is in constant need to be corrected. So the design of the lattice is also a process, or a tracing process, of the process of learning how the lattice works itself. Therefore, the notion of the myopic algorithm regulates local interactions of the process whilst tentatively trying to generalize them. Trees can be nested into lattices, so in a way, this third type can technically contain the other types, but we always have to be aware of the fact that by making this operation, we are grossly reducing the complexity of the lattice. Of course, the lattice ultimately finds in the rhizome its sort of conceptualization. But perhaps in this kind of discussion I find it perhaps more useful to point out that in the lattice we can only move conjecturally through conjectures, and the local rules of the myopic algorithm are somehow our set of little tools that we can use. So it's somehow navigation and search in this kind of environment are one. Now, these models, of course, find another turn in the late 1800s, when a kind of great intensity, if you like, in the field of mathematics, or perhaps better said, in the field of philosophy of mathematics, sets really the foundations of computation as we know it today, testing basically the limits of computability. However, at the beginning of the 20th century, Andrei Markov presents this work, which is 1913, though we know that Markov was already working on it earlier than that, which is a mathematical treatment of a piece of text by Pushkin. And it's a very simple form of computation in which the text is divided into blocks of 100 letters each, and then counting the consonants and the vowels, and then refining this counting mechanism by trying to understand the probability of a letter being followed by another type of letter. So again, we are dealing with some form of myopic algorithmic thinking, operating in this case at the scale of the single letter, what was the single node in the metaphor of on the prosthesis of the labyrinth. The emphasis on the analysis is not, again, on individual letters, but rather on the relation between them. It's not really important where the individual is, but the topological model of relationships is what drives the work. And we have, of course, the introduction of statistical thinking in order to evaluate the distribution of these objects, and therefore, once again, make them amenable for further discussion. And as such, of course, we know is the first mathematical treatment of language that we have. And some form of, if you like, discovery of this text can be done even without knowing what these words really say. In the relationship, therefore, between algorithm and knowledge, I thought that the figure of the prosthesis had an interesting role. This is an idea that I take from Carlo Sini's books on automata, and hopefully I develop. So here the word prosthesis, of course, is not to be taken in any medical sense, but rather is a process of presenting, exhibiting, assigning something, an object. And when Sini needs to discuss perhaps the relationship between prosthesis and knowledge, he turns to Nietzsche and uses Nietzsche's description of the process of how knowledge emerges by saying that this is a process of moving something from the domain of the unknown or stranger into that of the known or familiar. So again, this concept of the unknown object opens up a complex process in which such object needs to be made somehow intelligible. The aim, however, should never be to make the final result familiar, which would terminate the process of learning, but rather to improve its intelligibility by highlighting aspects of it, by realizing the artificiality of the whole process, and ultimately by foregrounding the incompleteness of the process of learning. So for Sini, this is labor. The act of knowledge is an act of labor in which the constant poking, if you like, and the constant feedback loop is essential. And I thought that the example of the marching cube algorithms, maybe time-wise, don't have time to go into it, but it is a simple algorithm which seems to exhibit all these characteristics, or is amenable to be discussed according to these characteristics. So as a way of concluding the presentation, I now want to move a little bit on how some of these ideas may be of help when we work with some of these concepts. So from now on, all the images come from the work developed at Bartlett, at the School of Architecture at UCL, with the collaboration of Tassos Varoudis. And somehow, all have to do with design and use of machine learning algorithms. So I think that somehow, again, the work has been also triggered by this idea of trying to overcome the notion of the perfect slave and increasing the scale. Scale here has to be taken in the abstract sense, the scale of operations. So one thing that we find interesting is perhaps the possibility of designing things all at once. You know, this is, as in, contrary to other, if you like, approaches to use of computational tools in design, we no longer need to segment the work to only analyze parts of it, but even in a myopic fashion, we can eventually analyze it all at once. And this ability to relate parts and wholes, I think, is an interesting concept that is reinvigorated by thinking about these processes along these lines. So entire data sets can be manipulated very simply, at least conceptually, and that is one, I think, element that is, if you like, of novelty in this work. Another element, this should play, but it's okay. Another element is, of course, the tension between the spaces, these two spaces. The one on your left is the geolocated position of data, and the one on your right is the same data set displayed in the abstract space of the computation. And the tension between the two, I think, is quite productive because somehow collapses certain ways of discussing this work that architects have used since the past 20, 25 years. Particularly, what comes into crisis is the somehow spatial hierarchy of the work. The work can no longer be discussed in terms of top-down or bottom-up. These categories don't seem to be particularly interesting anymore. And again, returning a little bit to this idea of the myopic algorithm, we have a much more interesting relationship between the part and the whole, in which one tentatively moves towards the other. And somehow the algorithmic process, in this case, let these conditions speak, let this condition appear. So maybe also it's interesting to think about this very formally. Why not? And and to see how perhaps there's only the possibility to articulate this kind of work in spatial terms through discrete morphological languages that can take on more discontinuous organizational principles, the ones that somehow seem to emerge by the collapse of these two spaces we saw in the previous slide. These can be layered with different qualities and can branch out into several potentially independent systems. What can be gained is the possibility to work with both the granular qualities of the individual and its relationality, and continuously move between this and the whole. So the notion of the fragmentation of the language, I think, is also a useful concept to try to work with these concepts. So in a way, like I said, the top-down and bottom-up concepts don't work anymore, and so doesn't really work the idea of parametrically thinking about these objects. In a way, it's not about parametrics anymore either. And in a way, parametrics presuppose somehow a certain process of idealization, which implicitly identifies an object or condition, no matter whether existing or not, from which to seed out a whole series of instances all related by continuous variation. This process leads to an idealization of the computational model, which goes beyond the inevitable approximation and reduction often accompanying the construction of a computational model. It implies a conceptual structure which ends up equalizing the actual distribution of values within a data set. When we work with learning algorithms, on the other hand, we have the possibility to register a more detailed spatial distribution of data as they employ numerical methods operating through iterative approximations based on refinement, statistical distribution, and correlation. Reduction towards some sort of idealized image is not part of their coding, and in a way, they are a lot more amenable to clustering distribution, inconsistency, discontinuities that cannot really be equated to formal continuity. So both categories, in a way, of top-down and bottom-up somehow coexist, and they can be used interchangeably. Somehow is the linear ability of one to account for the whole that doesn't seem to hold anymore. And this idea of thinking conjecturally, I think, is, again, perhaps part of this probing, this prosthetic idea that I spoke of at the beginning of the talk. So to conclude, really the fourth and final point is the possibility perhaps to rewrite one data set into another one. This was, for instance, discussed with the notion of the transcription in the first by Vera at the very beginning of the conference. So in a way, again, these operations of rewritings, which of course have echo in the field of mathematics and in the field of linguistics, seems perhaps more apt to try to work with the inconsistency and abrupt jumps in this kind of spatial distributions. By definition, these operations are relational and transformatives, and in mathematics, for instance, they can take on non-deterministic rules of transformation. The applications of such principles to morphological operations can be of great interest, as the result may be able to absorb spatial and scalar inconsistencies whilst remaining logically coherent. Rewriting would no longer be relying on ideals and exploit patterns and randomness within the bounds of the datasets computed. For this reason, even more granular fragmented design language offer richer variety to rewrite the various datasets with more articulated and nested, with more variation. This approach opens to a different aesthetics, no longer seeking smooth or continuous morphologies. So, in a way, these are some of the, these are somehow the conclusion, although they are still open, still the work continues, But I think that the use of certain images, if you like, from the history of architecture, and architecture understood both as a physical and as an organizational principle, were quite useful to try to mobilize some of the work we do in this particular field. Thank you.
Okay, thank you so much, Roberto. We open the floor for questions. Anybody? Yeah?
Thank you very much, Roberto, for the very nice talk. Because you finished with history, I just had a question. Also, as an educator, how does those processes and those views allow you to repurpose or rewrite also what the history of the history of architecture as a material with which to work as an educator for students? What kind of processes or what kind of manners do the students have to relate to historical precedents through those computational processes? Is that changing the view or the understanding of the corpus, the historical corpus of architecture?
Yeah, I mean, the part that I think that is, as the part that regards the work as an educator, has to do with rethinking the relationship between, let's say, architecture, physical or virtual architecture, and data. That is, I think, part of the ideas that we discuss. And with that, I think you have to re-examine the history of architecture, basically. That part is discussed, and we develop it basically through conversations. Then beyond that, I think is more of an individual choice of whether they want to, how they want to take this further, basically. But yeah, when we look at the history of the discipline, if you like, we look at it through these lenses. No? So it's hybridizing these two spaces, if you like. That is the part that is taken directly into the world of academia, to be straightforward about it.
Yeah. Well, thank you. It looks like beautiful stuff. I wonder if you could explain a bit more about myopic algorithm. At first hearing, this is the first time I've heard of a myopic algorithm. At first hearing, it sounds as though it's in some way a lesser thing than an ordinary algorithm because it's myopic. But yet you seem to be saying that because of that myopia, it actually has capacities that ordinary algorithms don't really have, at least relationally, because it's that allows the collapse of the distinction between local and global, top-down, bottom-up. So I wonder if you could tell me a little bit more about how that comes to be. Why is it myopic?
Well, in Rosenthal works, his definition is very simple. It is an algorithmic process to solve a labyrinth. So it can only go node by node. That's his myopic qualities. It doesn't know where the next node will be, and therefore he terms that lack of ability a form of myopia. And that, I think, is quite interesting. But I'm not interested in solving labyrinths, of course. It's been done already. So what I find interesting is by thinking along those lines, it's interesting to rethink the notion of scale, if you like. And that is, I think, how one can bridge from the original domain in which this notion was generated and the domains in which we work. So once you transfer it, you have a very interesting, very precise description of notions of scale. For instance, it's possible to rethink what myopic could mean in a spatial situation, but at the same time, it's quite complex how that localized action gets generalized. I think that's what is interesting. And and it allows you to think relationally. I think that's also the other part.
Is there any relation mathematically with fractals? It sounds a little like there might be.
But fractals are self-similar. This doesn't imply self-similarity. It can take things that are not self-similar. So I'm not a mathematician, but I would be hesitant to draw a connection to fractals.
More questions?
I would be curious to hear more what it is that we're looking on, and basically also with what you start in the class and how you end up with this then.
Okay. You are looking at some examples of very, very primitive forms of spatial rewritings. This is the first thing students do when they start. And these are morphological exercises in learning I suppose, the power and the limitations of algorithmically rewriting a data set. So this This 10 attempts to address the first part of the question, right? Then the second part was, how do you teach in general? Okay. The kind of the teaching is broadly divided into parts. You know? There's a certain level of literacy, if you like, that is very important to inject. And Emmanuel's question before also, I think, is part of this kind of conversation. How do you start? So that has to do with both technical and, if you like, intellectual ideas about these concepts. And then we start with this kind of rewriting processes. Now, what is interesting here is that they don't mean anything. They are nothing. They are not architectures that could be a house, this could be a... But it's a little bit like if you play the piano, no? You just have to go through the cycles and learn that I don't know how to play the piano. So I cannot really give you a good example for that. But you have to know the playfulness of that. And there's no real, I don't think it's particularly necessary to overburden the exercise with high ambitions to start with. Because at the beginning, when you start playing with an instrument, okay, there's Rachmaninoff, but we'll get there, okay? You don't need to do that. What you want is to learn the playfulness, because once you learn the playfulness, you can deviate, you can take it, you can customize it, you can make it your own. So these are just a few images of the hundreds that they develop to get accustomed to this thing.
Some more? Anyone else? Okay. How are we running on schedule? Are we early? Are we late? Should we proceed with further conversations, or do we have time for some more questions? if there are not any more questions, then we can move on to